Hello guys, you're welcome to another one of my videos. Now in the last video we took a look at using FFmpeg to do audio decoding, and we played back the audio using the mini audio library, and you can see that actually that video took about an hour to make. Yeah, can we actually get something simpler? If you think about it, apart from the explanations, using FFmpeg wasn't really that involved, but I believe that we could actually do simpler if we just care only about playing audio. The FFmpeg approach is kind of an overkill because there are actually simpler alternatives. All right. So that's what we're going to be taking a look at in this video, mini audio. Now, mini audio is not just a library that allows you to play back and record audio. It also allows you to decode audio and play that audio back. So basically, that single header file that you found that we had in the last video for just playing back audio actually contains decoders in them. Alright, and it's got a bunch of decoders. It's got a bunch of decoders for MP3, FLAC, Vorbis, and Wave, and some other audio, some very important codecs that are actually used, pretty much everywhere. Alright, so in today's video, we're going to take a look at how to decode and play back audio using this mini audio library. Definitely, we're gonna use the mini audio for the playback, and we're going to be using the mini audio decoder to decode the audio, and we're going to compare that to the FFmpeg approach, and we're going to see which one is actually easier and faster. Alright, so I've actually created a simple project here. Just like the last video, we have just the mini audio header file. Just click on the download mini audio.h and get yourself the mini audio header file, download it, create a simple project. This time I'm not going to be using CMake because it's just a simple project. I think that's kind of an overkill if I to want to use CMake in this case. All right, so I'm just gonna add the CPP right here to my project, and the first thing I want to do is to include the mini audio header file. Now, before you can actually use the mini audio, you have to define the mini audio implementation, just like that. But if you watch the last video, you're gonna see that when you're compiling this mini audio, it actually takes some time to compile because it's got it's got a bunch of things in it, and that actually takes a lot of time for the compiler to sift through and then finish up. So what we're gonna do in this video is that mini audio actually allows us to disable some of these things. So I'm gonna paste this here. So basically, these are the things that we're not going to be needing in this video. As you can see, mini audio actually even has the ability to encode audio, which is actually great. And I think we're going to be exploring the full strength of mini audio in subsequent videos. So if you're looking for something that is simple, fast, and doesn't require 100,000 dependencies, then you're in luck, because mini audio is going to check all those boxes for you, especially if you're working with just audio. All right, so basically the things we're not going to need in this video is we're not going to need null, we're not going to need encoding, wave, or FLAC. I'm basically going to be decoding an MP3, and if you know that, and I'm just doing this to make the compilation faster. Okay, so if you're actually creating an application, you wouldn't have to remove all of this. All right, just to make sure that the library is able to decode as much as it can. But just to make the compilation faster, I'm going to disable a bunch of these things because we're not going to need them in this video. All right, so once we do that, the next thing is to create ourselves a main function. Let's see, argv, just like that. A typical main function, the main function we know and love. All right, cool. So the next thing we want to do right now is to create a decoder. All right, we need to create a decoder so that we can actually start decoding the audio and playing it back. And unlike FFmpeg, where we had to create a format context, before we then found the streaming full, looked for some specific stream, and basically had to almost go to heaven and back just to get audio to play, or just to get our media file to actually get to the decoding stage. In this case, it's actually really simple. All we have to do is create ourselves an MA decoder, and that's it. So okay, I don't think I even have to initialize. I just have to create an MA decoder like that. All right. Once we create a decoder, what we have to do is check if MA decoder init file. Okay, MA decoder init file. It needs a path to our audio file to initialize the decoder with, and then it needs an MA decoder config. We don't want to configure our decoder. Whatever the decoder gives us, we're okay with it. All right, and we're gonna pass that decoder structure that we just initialized, that we created. We're gonna pass the address to it so that it's gonna populate the decoder with whatever it can find for this particular media file. Now, if it does not equal to MA success, then something bad really happened and we should abort the program. Alright, and unlike the last video where I was printing out error messages, in this case I'm not gonna print out any error messages. Print it out yourself. Alright, this is to keep the video shorter because I don't want to have another 1 hour video. Alright, so I'm just gonna get the media file, the same one we used in the last video. So I'm gonna paste that here, the path to the media file, and once we get that, that is all we need to actually create a decoder and start using it with MA decoder, with the MA decoder with mini audio. All right, so the next thing we have to do is to create ourselves an MA device to play back the audio, and to do that we create an MA device again. We call it the device. All right, and then we say if MA device init. Yep, I think, yeah. So it needs an MA context. We don't know what that means. We don't need an MA context. It also needs an MS device config. Okay, I think we're gonna need that because I don't know, how do we configure the device? Because we know that an MA device is actually a structure that can actually be used for either recording or playing back audio. So we need to give it an MA device configuration in this case. I'm just gonna pass in an address to a config that I haven't even created yet, and then the address to the device itself. And just as before, we're gonna check if it doesn't equal to MA success, something bad has happened and we probably need to call for help or just crash the program. It doesn't really matter. We're just gonna terminate graciously in this case. All right, now we need to create that MA device config I was telling you about. So MA device config, okay, just like that, and MA device config init, just like that. And now it needs an MA device type. Well, very good. MA device type playback. Why do we pass in MA device type playback? Because we want to play back the audio that we get from this decoder. So we pass in MA device type playback. As you can see, we got a bunch of them. MA device type capture, duplex, blah 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 blah. But we care about playback, so we're not gonna take a look at this other shit. All right. So the next thing we have to do is, this isn't good enough. Like for example, the device needs to know how, what is it gonna play, what's the sample rate, the sample format, and some other things like that. So we're gonna do that right now. So config the sample rate is gonna be the decoder's output sample rate. Wow. Config.channels, that's gonna be in the playback.channels. All right, decoder.output output channels. Yep, that's correct. We're also gonna need to specify the playback.format and the decoder.output format. So specify the sample rate, channels, and the format. And the next thing we need to specify is gonna be the user data. So config user p user data is just going to be the pointer to the decoder. This is so that we can access the decoder inside of the callback function, right? And then config dot p data callback, and we're gonna call it data callback. Now we don't have a data callback function. This is the function that is gonna be called when we need to populate the device with a new frame, with a new audio frame. So let's take a look at what the data callback actually looks like, because I can't remember the function signature. And since this is a header only library and the function signature is actually inside of the header file, we're just gonna check it out. If Visual Studio Code is gonna help us with that, of course. Oh, thank you, Visual Studio Code. Alright, so I get the callback. I just copied this the function signature, and I'm gonna put it here. Data callback. That's not necessary. Yeah, we got that. Now we're gonna get the decoder out of here. MA decoder pointer, call it decoder, and it's going to be I'm just gonna use the C style cast this time around, because having to type reinterpret cast is kind of too long. So I'm gonna have p device p user p user data. All right, once we get the data, what do we have to do next? Well, if you think about it, what do we need to do? We need to get the data from the decoder, and it's very simple. MA decoder read PCM frames. Ooh. And we're passing the decoder, and it's asking for the p frames out, so we're gonna pass in the p output. I'm gonna paste that right here. It's also asking us for the number of frames. Well, we got frame count here. Ooh, so we just pass that in, and take a look at that. You might wonder, wait a minute, is that all? Really, that's all, except for one more thing, of course. Our trusty get char. All right, now let me just include stdio.h so that we can have the get char signature. So this is gonna wait for us to press a button before, you know, all hell breaks loose. Oh, and I'm forgetting something. We've initialized the device, but we haven't actually told the device to start yet. So the device is not gonna do anything. All right. So we have to call MA device start. Okay, and the device pointer to the device. And if it doesn't equal to MA success, some bad shit also happen again, so you should probably check that. All right, but if everything's good, then we're gonna, you know, pass that stage, and we're gonna wait in this get char area. And now we should call MA device on init. Should learn to type. All right, so this is gonna be device and MA decoder on init and decoder. All right, cool. Now this is going to, so we're good citizens, we clean up after ourselves. This is very, very important. And as you can see, we did less than 50 lines of code. Wow, this is crazy. This is very beautiful. But we don't know if the program is gonna work yet, so I'm just gonna run it. C++ main.cpp. But now I have to link with pthread, because I learned from the last video that it actually uses pthread. I don't know what kind of threads he uses on Windows, for example. I'm sure pthread is available for all the other platforms apart from Windows. I think pthread is actually available on Windows too, but I don't know. I don't really care about Windows. So I'm going to be linking with the pthread and the DL library, and I'm gonna hit the enter button. And now I'm gonna wait for it to finish the compilation. Hopefully it's not gonna take too long this time. Oh yeah, and now if I run a.out, oh jeez, I forgot to actually give it a name. It doesn't really matter, we're just gonna execute the a.out. Right, and that's it. We just made this work. And you can see we even did better than the last video, because now we just have 47 lines of code, and I can assure you, I can guarantee that this is actually going to work on any platform. I mean, just gotta figure out, you know, what to link to with the thread and the DL thing. The DL is cross-platform, but the thread, the P-thread thing, I don't know. I don't know if DL is actually cross-platform. I think this is actually Linux, Unix specific. It's gonna work on Mac and Windows. Mac and Linux and Android, but I don't know if it's gonna actually work on Windows, because Windows really sucks. All right. Anyway, that's the end of this video. I guess I'll see you guys in the next one. Bye bye.